Well, okay, my friends, this is getting exciting. As you know, I've been talking about fascia and interstitium for years now, close to 10 years. And now they're starting to take a real deep look into this. This guy's David Lazantka, and he's an author and fascia expert. Now, here's what he's saying. Listen to this.
Tag everything as you're studying the body. The fascia you can throw in the garbage can. So it's almost like we're trained to...
See, they just thought it was fuzz. When I first started with this, there was a guy, his name is Gil Headley, and I watched his video called The Fuzz Speech. And he was the first guy I know of in the United States that was into fascia. And I contacted him, he was very gracious, never says, didn't want to talk about my research, I understand that. But he did answer my questions about anatomy. He's a autopsy guy. And he's doing right now a tour of Canada and the whole United States, doing conferences at, everybody's getting into this now. This is going to be the biggest thing in medicine ever, because they just missed it. It's this network of fluid-filled spaces that actually surrounds the fascia. It's not actually, this is where it gets a little tricky. It's actually the lymph that surrounds the fascia. That's my take right now. Okay, they get into fascia and yoga. It's the whole deal with yoga. And then there's massage therapy, and then there's acupuncture, and now they're using little vibrational tools and all kinds of things, ultrasound. I don't know what else they're using right now. But it all relates to, right now, I believe, is what I call the spurlock. And the fascia coats everything, yes, but it's just basically a coating. Where it attaches, that I believe is the source of pains, and the source of you need to make that pliable and stretchy. That's where the source of extreme amount of mineralization. After that, it sort of spreads out, well, let me show you something about a chicken breast. I show this every now and then because it shows it very well. Okay, my friends, this is getting exciting because they finally are recognizing this as a system, which is this interstitium. And it's a fluid-filled network that goes all the way around the whole body, but it has to be connected here and there wherever these body parts tag in together, because each one of them is completely enveloped in its own rubber bag, just like this long. And this is DNA tested, and this is basically how interstitium was discovered, is because of mud fossils. I was seeing it in my mud fossils. Now, what this is this is the complete rubber bag that coats this. So it's all by itself. Nothing can penetrate it. Nothing can penetrate it. That's the whole idea of a membrane and the interstitium. However, it has to continue to the next body part, and that's what that spot right there does. There's a little angle right on the bottom here. Here's a piece of meat. Again, a rock. And I can actually see where the transfer of the fluids is in this. Of course, you got to get in a microscope, which I have done many, many times. And these are what latches these body parts together. And your body is filled with so many attachments, it's unbelievable. That's why they're starting to get into this yoga and stretching, and, you know, this stuff gets sticky. It gets gooey and sticky. All right, they're called small leucine-rich proteins. That means they're slimy, and the factor of the friction in synovial joints, which is the same stuff as this, is 4 times greater slipperiness than Teflon on Teflon. This stuff it's got to be fluidy. If it's not fluidy and it sort of sits for a while and doesn't move around much, it'll get sort of gummy. That's why the stretching and moving and walking and all these things, that's just absolutely required. And especially as you get older, because you're just not moving that much anymore, to speak of. Plus your body is just deteriorating. I mean, let's just be honest. That's what happens as you get older. The alternative is it just doesn't work at all anymore. And so I go with being a little stiff. But you could get out of this. I was so stiff I could hardly lift my leg up to get my foot into my socks and stuff. It was getting bad. So I started doing very, very simple stretches, basically. And you don't want to do them to when it hurts, because when it hurts, you're just causing damage. You just want to do them to where you feel like a little bit of a oomph to them, and then hold them in that position for, at least 10-15 seconds, and then rotate around to another sort of comfortable position. You don't want to go, as soon as you feel a twinge, you just twinge something. You just pull a little, well, here, I'll show you what you did. All right, there's two different basic styles of tendon. There's a ponerosis, which is the flat sheets, and then there's the strap-like tendons and ligaments, which are rope-like. But it doesn't matter, because wherever they are, there's a tiny little straps that run through these tendons, and they're tough as hell, and they anchor in these balls. Well, you either snapped one of these, or you pulled it, or you stretched it too much, or you pop one of these balls. But that's what pain is you've created some kind of a inflammation-ish thing going on there, where you're just pulling too much, and they're too sticky. They have to slide between each other. Every one of those slides, and then, there are just literally thousands and thousands and thousands of them in each tendon attachment. All right, you see, I talked about a ponerosis versus rope-like tendon. This is a ponerosis tendon. And you see that abrupt transition between the extremely mineralized, tough as hell tendon, requires virtually no red blood. It's just like a rubber band, and I mean a tough one. And then it hits the muscle, and for a very short time, well, not a real short time, but a little bit, it gets still a little bit mineralized, and then I call them abrupt transitions. They'll be almost like a straight line across here. It'll change into another less mineralized, and then less, and then all of a sudden it goes into just straight, what they call sarcomeres, which are the tissue. They just fall apart. But up to here, it's just all strappy. So that's why you find a lot more tendons than you do muscle. Muscle didn't hold up as well as tendons. Now, the other thing I showed you was those balls and the straps, all the little wires that are coming out of the balls. Well, they run down to like bones, and this would be a bone emplacement of a tendon right here. Now, I was doing some experiments with copper and so forth, but see these little holes? All of that right there. This is where they come down and anchor right into here. And if you took that's just what it is. All of them have the same stuff. You see it? So that allows it to pull against something. Otherwise, you have no attachments. All right, and those attachments are where you have pain. And there's just bazillions of them. Look at all the different attachments there is. That could be painful. This could be painful. I mean, they're everywhere. These are specifically very painful down here in your hip joints, a lot of it. But you see the depth of tissue? You start out here at the outside of before this, you've got skin, and of course you got your little fleshy stuff over that, and then now you're hitting into your muscles and so forth. And outside here sits your interstitium. And then on every one of these is completely coated with its own membranes. All right, so everything flows this lymph fluid together. Now, you see it goes from here down to here, deeper, down to here, deeper, 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 all the way down to the bones. Now, every one of those layers is held off from each other layer by layers of membranes, which is basically fascia. All right, now I think there's a couple things they're missing here about this fluid-filled network, which they're calling now the interstitium. Now, this is one of these, this is actually this rock. And I've did all this biology using rocks because they preserved flawlessly because of the conditions they preserved under. Now, this is the tip, which is the attachment of this chunk of meat to wherever it was in the body. If it had a latch here or latch over here, wherever it was, that's the little flap that locked onto something so you could pull against it. That has to be tough, 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 tough. And it is. And I call it the spur lock. And here it is right here. In this particular case, somebody overstressed it and ripped it. That's supposed to be attached and, you know, but that's, somebody ripped it. Now, I believe, well, I know that the fluid has to go from this body part, whatever this body part was, is attached to another body part. You can't just dead end the fluid here. It has to go to that other body part. Now, that other body part may have 100% different chemistry. This could be acid. The other one could be salts. It could be just blood. It could be urine. It could be gallbladder material. It could be your enzymes. It could be whatever. But my point being is when you have an organ, and that organ, like this lung, I believe I showed you before, is completely encased, 100% totally encased. All right, the only place that the fluid can transfer is from here to where it attaches to the next body part, which is the same as that. This right here is basically the same as that. And they all have one of those little flaps. You see that flap? That's the same flap as this. You see that flap? And this is another lung. Now this, I think, is meat going to something, I don't know what it's going to, I got to be honest with you, but this is just a sports injury, so it's probably to some tendon here. But that's the attachment. Everywhere you attach something, there's a little lock. I call it the spur lock. And I actually can see it in here really clearly. Watch. Now, remember this, there's a ball right here on the end. You can't see it real good in this, but in the last video I did, I got it in the microscopes and all that stuff. I had like a bunch of them, and I showed this very, very clearly. Now, as it goes back from that lock, which would be laying on another piece of meat, another piece of your body, this would be on, locked in with this little button. You really can't see it. Well, maybe you can a little bit. There's a little flap that goes right around like this, and it just locks in. Now, going back, here's where the one in the back is, right here. You see that one circle? Take your time. You see the little circle? All right, it's not hard to see. This is it right here. And it radiates out. And this is very, very, very strappy and tough, and that is gnarly as hell. And that's the button that locks it in to this part. So this button here locks it into here, and it's very, very tough. And then you have all these straps coming this way and that way. See them coming across, back and forth, and all that. And this whole flap is what lays on the next piece. And this is the button that locks it in on the next piece. It's almost like a tab, like a snap. Because you got so many of these around your body. You know, it makes it convenient. You use the same kind of snap. I mean, just look at how many spots have to connect to another spot to hold your... There's hundreds of them just in your hands. Your feet, your toes, everywhere. A bazillion connections in your body. This is when you really dig into to anatomy and biology and chemistry, and how the systems of the body interact with each other, and the biology of breaking down food and changing it into edible products and building it back up into construction components and ending up with a sometimes thinking human being, rarely no, but at least you get the human being part. Anyway, this is off the charts, but it's all real now, and they know this fascia is the key to life. This is what protects you. This is what keeps you fluid and moving and able to do all the things you have to do in life to get by. And it is the immune system, and it is where in your guts and everything, that same fascia and that fluid-filled network is what absorbs all your nutrition and ribosomes to move them up through the blood barrier to just protect your brain. Again, I want to be involved in this research. I have a lot of information, and I've done my homework. So I want to be able to speak about it. And right now, you got to be one of the members of the club, basically, to speak. And I have, and I can see other people are seeing what I'm doing because they're writing basically the same thing I'm writing now. And I wrote it years and years ago. So, are they just rediscovering it? Maybe. But I just want to be able to present my evidence, and that happens to be very, very difficult to do. Even the people that are in the profession that are writing these papers, this guy that wrote about the interstitium, he said he had to submit it to 5 different places before they would publish it. And he's a PhD, biologist in, I think it's New York University. So they don't just take any papers, and they will absolutely. I can't comment on anything. I'm not allowed. I'm literally not allowed to be in that realm. That is pure. What happens with peer review? They won't allow you to speak if you don't say what they want you to say. Now, this guy, I think his name is Neil Tice, or something like that. He basically wrote the same stuff I'm saying. This interstitium, and it's in, it's a fluid-filled network, and all the stuff that I said about it, and even all the way down to where the claims I made about maybe it's the fiber optic network, and it's the immune system, and all of that stuff. The lymph is in there. I saw he just did another interview 2022 or so, that he said, well, maybe it's even related to all of the immunities we have. And it is, because that's where the bacteria and enzymes live. You don't have them there, you're going to get invaded. They are the first line of protection, is where they're interested at the fluid-filled fabric network is, that sits on top of the membrane. That's where you protect yourself. After that, all bets are off. All right, let me just lay this out for you. This is the interstitium, a newfound organ. This was just published in 2018. Now, here is where the interstitium is that white layer right there. That's a fluid-filled network of these little fascia fibers that they never took into account before. It was just a fuzzy thing. They just basically threw it away. Now, below that is your membranes. All right, and they always say, well, that's a membrane layer, and this was a dense mat on top of it, because by the time they looked at it, the fluid was gone. When I saw it in my mud fossils, I could see there was fluid in there. So I contacted people about this in Germany and all over the world, and very few people, almost nobody knew anything about it. Really only one guy did. And he knew, he was an autopsy guy, so he knew what I was talking about. But he said they just throw that away, it's fuzz. And I said, well, I think it's got, something's going on there. It's not just fuzz. So after a year or two, we got to the point where he took another look at it. He did another video called, oh boy, I can't remember, something, reconsidering the fuzz. Because before, they just throw it away. It was like, and even this guy, I think I showed it, or I will show it, he said, yeah, it's just stuff we just threw in the garbage. Where after they were doing autopsies in medical school, they would show them, here we're going to cut this little piece out, I throw that out, it's just trash. No, that had to, those fibers somehow connected through this whole thing, and they work with this layer here, your membrane, to move all the products through your body. This is expendable. Skin and the outside coating of the membranes, that really is not something that's going to kill you. They're meant to be attacked and repelled by these things here. But once they get to here, if there's nobody going to stop them, right through, that's when you get cancer. All right, so what did I just show you? I showed you this membrane, but the thing they didn't know is on top of this membrane is the fascia that just lays on there. And that's that gooey, gummy stuff that they just threw in the trash. That's where all that fuzzy stuff was that I showed you or will show you, all these little fibers. And in those fibers is the lymph. The lymph is what transfers all the stuff back and forth, basically. And it may be a communication source because it touches every single cell in your body. The lymph fluids and the lymph ducts, which I can show you in the pictures that anatomists would never be able to see. I'm going to show you something that's going to knock the socks from your toes. This, my friends, is the membrane. Above is the interstitium, what they're calling now, is that fluid-filled network. Let's take a look at one that, like I said, get your socks glued because otherwise they're gone. Okay, my friends, get ready. This is going to be another shocker du jour, home of the shocker du jour, Mudfossil University, home of the shocker du jour. And as promised, get ready. We're going to be looking at some new techniques to discover the chemistry and the biology of the immune system and the flow of fluids through the body, blood, and all the types of blood, the artery, the vein, and then the lymph system, which is not understood. Because the lymph, literally, I believe, and I will show you, and we can open up for debate to some professionals, but I'm going to show you a technique nobody's understood ever before. You, the privileged ones, are about to see it. Get ready, because here it comes. Okay, let's take it from the top. What do we see? You know what? Hold on. Let me turn this light off. Maybe that gets a little better resolution. And that one. Okay, let's see if this works. Now, this right here, the black, I'm going to tell you right now, is a vein. These are arteries, the big ones. What comes off them are the blood vessels, and then they lead all the way down to the capillaries that are the last things, and they discharge into the veins. That's the network of dispatching and retrieving blood. It comes through with all these little black spots in here, which are all nutrients and so forth. And those nutrients passed along into the cells as it comes through, and then there's a few left over here and there, but not much. By the time it gets down to here, all those nutrients have been pretty much used up. It's hitting a bazillion cells. This is hard to say how to say it. It's like toxified off the top so we can see what's below. This is a new technique. Nobody's ever known about this before, so you are numero uno to see this. Now, I have closer shots of this, believe it or not. So don't forget, these are how it sucks the black vein blood back up. And this is how it delivers the red blood. Now let's get a closer shot. Okay, so you see what you got here? There's a couple things you can take away from this shot. You see all the little spots? These are all, that's nutrients. You don't see them out here. They're only in the blood, being carried by the blood down. You don't see any of those here, not a single one. Now, so what happens at the end of the journey of the blood? Primarily, all of the good stuff is absorbed by the tissues of the body. They've broken it down and they're using all of that product that the blood is delivering. Now, what happens after that? It has to go somewhere. There's still a bunch of plasma with the watery substance that brought all this stuff down. So it has to go down into the veins. And these are the veins right down here. And between the arteries and the blood vessels, you have the capillaries. Now let's take a look at those. All right, so here we are at the capillaries. Again, it's all using up this good stuff, and it dumps whatever's left over into the veins. Now, the veins collect a whole bunch of garbage, basically, and they bring it back to be reprocessed. That's whatever's left over, they take back. That's what your veins do. Now, So this is the last little squeeze, and that's what the capillaries do. They pinch, and what it does when it pinches the fluid out. And where does the fluid go? Well, the fluid goes into the lymph ducts. And the lymph ducts are what your fascia is, I believe. Now let me show you what the lymph ducts look like. All right, you see these tiny little lines? Those are the lymph ducts, which is the fascia, which is laying on top of this tissue layer. Now, you see what's happening here? This little pinch, this little pinch, this little pinch, pinch, pinch. That's how the veins work. That's how they absorb into the veins all the leftover garbage. And they bring it back up to the heart or lungs, and they recycle it. Now, so what do we had? The arteries, the blood vessels, the capillaries, and now we want to look at the lymph system, which is this right here. Let's see if we can see a better shot of that. All right, here it is right here. This is that fluid-filled network of little tubes. You see them? They're everywhere. That's exactly what it shows you when they did that autopsy. I think you saw that. I'm not sure, but I believe you did. And of course, this is the vein dragging up all the other stuff that's just leftover garbage that's got to be recycled out of the system. And this is what pulls all the fluids back. And you see how tiny these fibers are? And when I say tiny, I'm talking tiny. Tiny. And that's why that's the lymph. But it's in this fluid-filled highway of the fascia that they just never took into consideration before. Now, I don't know how much of the fascia itself. I believe it's the fascia network that they just, basically the lymph network that they just never knew was there. So even though they're calling it interstitium, I call it the lymph network, because this is, I believe, what they're finding. And that is really where all your immunities exist. This is where the fluid-filled highway can send anything, anywhere, anytime it wants. And it's a giant connective tissue system that has to be tagged together at all of these points I call the spurlocks, which are wherever one organ or one body part meets another, they have to tag in. And all these fluids have to drain through here out into the other one. Because the whole thing's one system. And this is just a bag on its own. Just like every other organ in your body is a bag on its own, dealing with its own chemistry, and then squirting out through the little tiny spurlock to the next organ or to the body, wherever it is. This is a very, very important part in the system, is this little latch, and they don't understand this latch. Nobody I know does. Maybe they do, but they're hiding it if they do. And it's this latch right here. It's that latch right there. It's the same as basically that little latch right there. Only these hold in the chicken breast. This has the same sort of flangey looking thing, see? Coming up here, and then it works its way into the bag and just becomes part of the bag. Just like this, it comes up like that. Kind of heavy duty. Remember I talked about abrupt transitions? There they are. And at that point, it's sort of, you still have a membrane, but it gets a little less fibrous because it doesn't have to really hold. You're pulling on this all the time, pulling back and forth. That thing there is unbelievable anchor. These are just unbelievably tough, absolutely incredibly tough. So, and they are tough, and they're now known as the spurlock. So now I'm sure you're wondering, how would Roger get access to this kind of photography, which the top doctors in the world don't have? They've never seen the lymph system, I don't believe. If anybody has, that's been kept a pretty good secret. Now I just showed you the lymph system is basically this fluid-filled network of tubes that run through your whole body and connect as one giant system. And again, that was, I don't want to brag anymore. Well, yes, I suppose I do. I wrote the paper on this. I wrote the paper on the fascia facilitated fossilization, which showed everything in fossil form, perfectly preserved. Basically like you're seeing what you're seeing here. There is just an actual perfect shot of what I have because it was preserved basically instantaneously. And if anybody wants to know how these pictures were taken, and they're a doctor or a surgeon or anything like that, I'm certainly willing to discuss that with you. But if anybody says these are not biological pictures, I would like to have some reasoning behind that. I think I've shown extremely clearly what they are. And if anybody can dispute that arteries come in big and they have vital fluids in them, which you're not seeing any of these things over here, no vitality there, only in the borders of the arteries. And the veins, you're just seeing garbage. And the capillaries, I mean, this is all undeniable stuff. And the lymph ducts are they're just everywhere. And those appear, to my way of thinking, to be the fascia. Okay, remember, that's the fascia we're talking about. And that lays right on top of of what they would call the membrane, the interstitium layer. I'm not sure they understand about this yet. Well, all right, this is my contention. This fascia is where the lymph lives in your system. It's a fluid-filled highway, and these are the fluid-filled little highways. And that is the fascia that coats everything, the interstitium they call it now. And this literally is the source of the protection of everything, because it coats the membranes. The membranes separate you from the rest of the world, and they thought that was the only thing that did. No, there is this on top of the membrane. This is what's been missed. This stuff right here. All right, pay attention to the details here. We are on top, braiding everything down till we get to the top of the fluid-filled highway, the network, which is basically the fascia. Now below that, you see, this is running over the top of this. That is the vein, and it's carrying up all this debris. I don't know what it is, but it's bringing it back to the heart. Now, you see them here, you see it here, you see it here. Now, to me, I believe this is where the transpiration happens between the leftover fluids, sucking it back into the body, either out of here or in that area or wherever. It's more intense right in this area. But these are all these little lymph fluid ducts, which I don't know if they do know that much about the lymph. They know there's lymph fluids, but I don't know how much they know about it, to be perfectly honest with you. But I believe this is where the lymph exists, and in that lymph is where the ribosomes and enzymes and proteins and bacteria live. Because they're small enough to live in these very, very tiny things. A ribosome is so small that you could have millions of them. Literally, that's what they say. You could have millions of those ribosomes, those single little tiny balls, in every single cell in your body. And if you knew how many cells were in your body, it's just staggering. All right, so that's what I'm saying. That's the lymph ducts, and it is also the fascia. It's also the immune system. It's the source of enzymes. Well, it's not the source, but it's the area that moves the enzymes, and they live, I believe, in the membranes just below, but I'm not certain of that. They may just live right in here. They just may live in that lymph and do everything they need to do in there. I don't know. But they are a ton of bacteria in your body. Now, I got to look into the lymph, if the lymph, houses bacteria. I got to look into that. Hold on. All right, yes, it does. Lymph fluid can contain bacteria. Lymph fluid is a collection of fluid. There's 4 times more fluid, this lymph, in your body than there is blood in your body. That's what they claim. The lymph fluid is a collection of fluid that drains from the tissues and cells, primarily right at that point where they're going to enter into the vein. It can contain bacteria and other foreign material. Lymph fluid also contains other substances such as, this is really interesting, interstitial fluid, which is the enzymes, lymphocytes, which are another protector of your body, cellular debris, sure, plasma proteins, those are the things that build you up, minerals, fats, nutrients, and damaged cells. Well, there should be something that comes in to take those cells out. So those damaged cells are obviously, you got damaged cells everywhere in your body. So you need other bacteria to come in and remove those. So that's off the table. It contains bacteria. Your lymph is floating through your body with this bacteria, squirting out all these ribosomes. The ribosomes are so small, like I said, they can go through the blood-brain barrier, no problem whatsoever. But once they get on the other side, they explode into their magnificentness. And when I say magnificentness, let me show you precisely what I mean. Hold on one second. All right, so we know our lymph has a bacteria. This is a bacteria, single cell, one cell, tiny, tiny, tiny. These are the ribosomes, and they are tiny, 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 tiny times a million. Now, they're little balls, and this thing just floats around and driving wherever it wants, I suppose, squirting out these balls. That's its program, is to squirt out these balls. Now, if this is bacteria A, it squirts out ribosome A. If it was bacteria B, it squirts out ribosome B, C, D, E, or A, forever, until and there's literally tens of thousands of different types of bacteria, all squirting out different ribosomes, different chemistry, different jobs. All right, so that squirts out. Where does it go? What does it do? All right, you saw the ribosomes, these little round balls. They're like this, and they just float around through your body. They call them free floaters. They go anywhere they want. And it appears that they enter into cells. They're allowed to go into the cells. They're so small they can go anywhere they want. They seem to collect, apparently, inside of cells, hundreds of thousands of them, millions of them, inside one single cell. So don't forget, there's thousands and thousands of different chemistry sets. So maybe all of them go into every cell. It could be. And they only activate if they're being called on. And what is that? That's the trigger. So the ball comes in, I'm having a good time, I'm just laying around. They don't poop, they don't eat, they're not alive, they don't do anything, they just lay around. But there's some kind of a trigger mechanism on them that when this trigger hits, pew, well, what does pew mean? Well, pew means this. Zzz, the sheath comes off. The particles open up like a gigantic web, and I mean huge and magnificent, extremely deluxe, high quality, superb enzymes. Well, what else did they do? If it was a different type of bacteria, maybe your bone says, hey, you come here, or come here. And you say, well, yeah, what do you want? He said, I want some bone. And he said, okay, no problem. And it comes out with a protein. And the protein is a bone, and it does this. All right, and it builds something to make a bone. So it builds or it breaks. They're the same basic process. Same deal coming out of an enzyme, of bacteria, which is the enzyme, ends up being this. But in the meantime, you're a ribosome, unsheath, boom. Now, what does this mean to the blood-brain barrier? Blood-brain barrier is so tiny that these enzymes are much too big to enter that. However, this is not. That is not. So when that little ball goes up to the blood-brain barrier, at the very tips of all the little bits and pieces that are in your brain, there's a little restriction there that says, no, too big to get in here. Well, this is no problem. She says, go ahead. Yeah, no, go ahead. So you go in there, and then you're inside the brain where, if you're needed, you just get popped out like this. Now you're good. But you can't get this from your body to go up through those blood-brain barriers. They won't allow it. So you need to have this, which requires a bacteria to make that. That's what a ribosome is. It's from a bacteria. So that's the problem with a lot of disease. There's no ribosome to do the job. And the reason there's no ribosome, there's no bacteria. There's not a big stretch here. So don't forget, this is what happens inside anywhere that one of these is being used. It just gets in there and it starts laying around. And something triggers it. Something goes click, and it bounces something off here like that. And it says, oh, there's the guy that we got to attack. And it goes, poosh, and I mean instantaneously. And when it does it, and it attacks something, the attack is so fast that it's just like a quarter of a second, it wipes out a whole batch of things. And the reason is, it's an enzyme. An enzyme does what's called click chemistry. All of these are magnetic signatures. You see the blue and the red? That's positive and negative. Let's go with that. Now, and it's got to be exactly that form. Exactly. And when it comes up to what it doesn't like, it goes click, 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 click. And I mean just done 10,000, 50,000, 100,000 a second. Millions a second. This thing speeds up the rate of chemical reactions up to, sometimes they claim, as high as trillions of times a second. So it would take years to do the chemistry that this can do in less than 1 second because of its molecular signature here. In less than 1 second it can do the chemistry. It would take years to happen naturally. That's what an enzyme is. The only way you can get them, the only way you can get that magnificent, exquisite molecule is from an enzyme and from a bacteria. It just doesn't get any simpler than that. So don't forget, this is the stuff we're talking about. Fascia interstitium. Okay, and my claim is this is the biology of the interstitium. And I made it pretty clear in my statements what this is. And if a doctor or any physician or any biologist would like to, anatomist, whatever, would like to discuss this and how I arrived at these magnificent pictures, I'll be glad to discuss it. Now, I'm not going to show it today, but I have other shots showing the actual interstitium fluids attacking invasion of caustic chemistry. So it actually, the fluids in here went out to try to retrieve that caustic chemistry and ended up killing the lymph nodes. And I can show all of that, just like I've shown you this in exquisite detail, down to that level where we can see the interstitium, which is the fascia basically, sending troops to attack these invaders and being overwhelmed. And again, this is me. That is me. Now, if somebody wants to get a hold of me, a doctor or whatever, biologist, and see what this is all about, I'll be glad to do that. Because I think I now fully understand, well, not fully, but I understand a lot more about the immune system and the transition of enzymes and bacteria through these little networks and how they affect health and stability and pain. It's all, the whole thing is related. 100%, it's all fascia. I'm telling you, this is the biggest thing that ever happened in medicine is happening right now because of fascia. Because of fascia. Trust me, I ain't lying. All right, I love you all. Stay tuned to the fascia. Keep your eye out because this is big now, huge. And I have a friend. He goes all the way around the world teaching about the fascia, and he does seminars in big auditoriums and all that. And he's done United States. I think he's doing Canada now too. It's been a whole year. He's been out on the road, going to all these places, and he's a real good guy. He's the guy I started with, Gil Hadley. And again, he doesn't endorse anything I say. I never talk to him about any of my Mudfossil stuff. I ask him questions about, what do you think this might be? What do you think that looks like? That type of thing. And he just says, well, it looks like this, or it doesn't look like that. That's all. No, he's not committing himself to anything of my stuff. But I am. I'm telling you right now, that is, as far as I'm concerned, that's your fluid-filled highway. And and there's somebody else trying to get a hold of me too, but that's my email address. They claim it didn't work. I don't know. Seems to work. So if you need to get a hold of me, that's the address. And I can't get overwhelmed with stuff, which I basically am at the moment. So something, try to be brief if you're going to get a hold of me. And I got to be honest with you, I may not get back to you. I'm just overwhelmed. But as somebody that has some influence in this sphere, I would certainly love to hear from her. Because if you're into this, and you're really a scientist, what I've just shown has to stimulate you to some degree of some interest. And I'm here to fulfill that interest. Thank you. Love you all.